All right, Algebra 2 students. For the rest of the school year, we're just going to be reviewing. We're going to review everything that we've learned since August up until now, and we're going to be closing out the year with a final on all this stuff, so I would highly encourage you guys to keep a nice, neat record of everything that you have. If you want to take notes on these as you go, that might be wise too. It's up to you. I'm going to do a worksheet myself with you guys, and each of these problems is meant to kind of help you guys do your worksheets as you go, just like I have been doing. But ultimately, you can write down the ones I give you for notes, and then you can do your homework just for the homework credit. That would probably be the best way of going about this and keeping the notes with you. If you want, I can even post the teacher examples online so you guys can just print them out if you have a printer, and you can just copy the notes down directly onto the worksheet and keep a record of these notes for your final that'll be coming. That would probably be the best way to study. So I'll say that again. The best thing you can do is I'm going to post these teacher examples as well as your worksheet. The worksheet is just for your homework, practice purposes, but the teacher examples, I would encourage you guys to print those out if you can, and then take notes directly on this worksheet as you watch the video, and keep a record of all these for the next 5 or 6 weeks as we review everything since August. Keep it as a record to help you do well on your final. Okay. So what are we going to start with reviewing? We're going to start talking about linear functions first of all. We're going to talk about how to graph them. That's the first 6 problems. We're going to learn about how to write linear equations from data. So instead of turning an equation into a picture, we're going to take some elements of a function and turn it into an equation. And then we'll also just talk about solving some basic linear equations. Then we're going to move into systems of equations. We'll talk about solving them by graphing. We'll talk about solving them with substitution and elimination. And then we'll close out this particular review session by talking about functions and operations on functions, plugging numbers in, adding functions together, dividing them, finding inverses, etc. So there's 30 problems altogether here as I go through these teacher examples. All right. You don't have to watch all of them, just skip through the video and watch the ones that you feel you need help with. Let's go ahead and begin. So when you're trying to graph a line in the form of y equals mx plus b, the b tells you where to start on the y-axis. This number is your slope, and it tells you your rise and run. Okay, so for this part over here, number 1, I'm going to be starting at -4 on the y-axis. Then my rise and run is 1 and 5, so I'm going to go up 1, run 5. So from this dot, I go up 1 and over 5. From the 4, I go up 1 over 5. And after that, you just connect your dots, and you're good to go. Okay. Now for number 2, you'll notice that we're missing some things. We don't have 2 numbers for our slope, but we can make that solution easy to solve by just putting it over 1. So now I see that my rise is 3 and my run is 1, but we're still missing the b. When that one's missing, it's a 0. So if you're ever missing a rise or a run or both, those are 1s. But if you're missing your b, that's a 0. The reason for that is because adding 0 is like adding nothing, right? So 3x plus 0 is the same thing as just 3x. Or multiplying by 1 is the same thing as not multiplying anything at all, right? So that's why it's the difference between multiplication and addition, which is the reason why you do 1 versus 0. Anyway, I'm going to start at 0 on the y-axis. I'm going to go up 3 over 1 from that point. Connect the dots. Continue here. Number 3. So on number 3, we're missing the slope, so that means it's 1 over 1. But notice there's a negative in the front. That matters. I'm going to start, first of all, at my y-intercept of -1. Now, since my slope is -1 over 1, that means I'm going to go down 1 when I go to the right. Instead of going up 1 and over to the right, we're going to go down 1 and over to the right. So that's going to look like this. And connecting your dots, we have that. Every one of these examples is to illustrate something different. Number 1 was the basic idea. Number 2 is how to deal with missing numbers. Number 3 is how to deal with negative slopes. Number 4 is another situation to be aware of. Notice it's not in slope-intercept form. This y equals mx plus b is what we call slope-intercept form, but this one is not. Now, the way that you get something into slope-intercept form is by getting the y variable by itself. So I'll show you how to do that. So the first thing you're going to do is you're going to move the x term to the other side. Now, since that x and that 9x and that negative 20 are not like terms, we can't actually combine them. So all I'm going to do is I'm going to put them next to each other, like that. The next thing I'm going to do is I'm going to divide both sides by the negative 4. So we're going to divide out the number that is in front of the y. So in this case, 9 and 4 can't really be simplified, but their negatives do cancel out. So we're left with 9 over 4x. And then negative 20 divided by negative 4 is positive 5. And now we'll just graph it the same way we graphed the last 3. So that's kind of the new part to this problem. Knowing how to get that y by itself so it's in the right form to graph. So we would start at 5, and we would go up 9 and over 4. Now, this one's kind of a pain in the butt, because it says to go up 9 and over 4, but the problem is that I can't go up 9 because my graph runs out. Now, you have two options. Option 1 is just to kind of make your own spaces if you want to. So up 9 would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'd probably be somewhere up there. And then over 4, so that would be, we can go over 4. That's easy to do. So you could do that, right? Another way to do it, instead of going up 9 over 4, you could do the exact opposite. You can go down 9 and left 4. It would give you the same outcome. So down 9 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then left 4 puts me here. So either way, though, you get the line that you need. All right. Next one, y equals 4. Now, the next two problems are unique. These are special problems. Anytime you have a y equals a number, those are just generally going to be a horizontal line. And when you have x equals a number, those are vertical lines. So what you're going to do is you're going to find where does y equal 4. If y equals 4 right here, and you're just going to draw a horizontal line through that. That's how you graph the line y equals 4. Whereas the line x equals negative 2, you're going to find where x equals negative 2, which is right there on the x-axis, and then you're going to draw a vertical line. I didn't draw it very well. Still didn't draw it very well. Let's try again. There we go, a little better. A vertical line, negative 2. Okay, so that's how you graph the ones that have only one variable. All right. Continuing on, I think I'm going to change screens for the rest of these. Okay. Write the slope-intercept form of the equation of the line through the given point with the given slope. So I'm giving you a point and a slope. Okay. So slope-intercept form looks like this. And to have a complete equation, we need to know what m is, and we need to know what e is. All right. So the first thing that we need to do is we need to make sure you guys know what m is. M is the slope, so they tell us that. That's kind of convenient. M is negative 1. The next thing we need to do is we need to find b. Now b we don't know. So b we're going to have to solve for. So we're going to take this little formula and we're going to plug in everything we know and solve for b. The 3 is an x, the negative 4 is a y, and the slope is a negative 1. So I'm going to plug those numbers in for each one of those letters. And now I can solve for B. Turns out that B is also -1. The last step is to go ahead and write your equation. The way you do that is you just take this expression and you plug in the two numbers that you wanted. So we have y equals -1x minus 1. Now it would probably just be written like this, because usually if x has a 1 in the front, we don't write it. Okay, so that's how we find the equation of a line with a slope and a point. Let's take a look at another version of this question. Sometimes they'll ask you to do the same thing, but they'll just give you 2 points. When that happens, you have a little bit more work to do to find your slope. In this case, we don't know what our slope is. So instead, we're going to use the slope formula. y2 minus y1 over x2 minus x1. Each of these pairs is an xy pair. We'll call the first pair the 1, the second pair the 2's. It doesn't matter which pair you call the 1's and which pair you call the 2's. But from here, we're going to go ahead and start plugging some numbers in. So based on how I labeled them up at the top, I'm going to start with y2. y2, I labeled that as the -2, minus y1, which is a -4. Notice I've got double negatives there. The middle one is a minus that comes from the formula. The next one from the number -4. On the bottom, we have x2 minus x1, so that would be 0 minus 5. Simplifying this up a little bit, like we said, the double negatives becomes positive. And then we go ahead and simplify the numerator. -2 plus 4 is 2. 0 take away 5 is -5. So there's my slope, -2/5. And usually when you have a fraction that's negative, we don't really put the negative on the top or on the bottom. We just kind of put it in front of the whole fraction. All right, that's M. Then once again, we got to go and find the B. We're going to do that. From here on out, the problem is pretty much the same as it was last time. We're just going to plug in the M, the X, and solve for the B. So now, I guess there is a little bit of a difference, though. The difference is that we have 2 points to choose from. So it doesn't matter which one you use. I'm just going to use this one. Okay, so I'm going to plug in -4 for y. I'm going to plug in -2/5 for the m. I'm going to plug in 5 for the x. And we want to solve for b. All right, now another difference about this particular problem is the fact that we have a fraction involved and nobody likes fractions. So let's talk about how to deal with that. First of all, I need to multiply these two numbers together. So I want to think of this as a fraction also. And what we do is we just do top times top and bottom times bottom. And what that's going to give me is -10/5. Now sometimes you get lucky enough to be able to reduce this. And in this case, it reduces. But if this fraction doesn't reduce, what you would do is multiply every term by the bottom number to cancel it out. Okay? But in this case, we actually get a little bit lucky. This reduces nicely, and we just end up with -2. So from here, to solve for b, I just need to add 2 to both sides. And we end up with -2 equals b. And so to write our equation, WE for right equation, we're going to write y equals m, which we got -2/5 for, x plus b, it's a -2, so I'm just going to put -2. So the problem is a lot like the last one. You still do the same steps of finding your m and b and then writing an equation. It's just that finding your m is a little bit trickier because you have to find it this time. It's not just given. Also on this problem, you have to deal with fractions a little bit. So let's take a look at another question. So on this one here, you can approach it the same way we did the last problem. It's just that you have to pick your own points to work with because they didn't give us any points. So what you want to do is just pick some points that are there. Like I know this point and I know this point. Those 2 points have the coordinates of 4, 2 and 0, -1. So once you pick 2 points on the line, you can go through the same exact steps we did on the last problem. We can call this pair xy 1s, and we can call this the x2, y2 pair. So now if I wanted to find my slope, we would just do y2 minus y1 over x2 minus x1, which is -3 over -4. The negatives cancel, and we have a slope of 3/4. So that's how you can do it. Or you can get kind of creative here and just realize it's over 4 up 3. The only problem with doing it that way is you have to be careful with your signs. Right is positive, up is positive. You have to remember that left and down are negative numbers, so you have to be careful with your signs if you're going to do it geometrically. But the formula works as well. Now, the next thing we have to do is we have to find our b. Now, to find your b, you're just going to take pick a point, plug in your y value, your slope, and your x value from the point that you picked, and solve. So this is going to be 12 over 4, which is 3, and then subtract. I get b equals -1. But once again, you can tell that just by looking at your picture. It's right there. The b is the y-intercept, so it's -1. So if you have a graph, just go ahead and use the picture if you know how to. It's a lot faster. Finally, we're able to write our equation, which is 3/4 x minus 1. And there you have it. That's how you find the equation of a line. 3 different ways. Now we'll talk about solving equations. I came up with a little acronym, and I've always taught it this way. It's don't call me stupid. But what it really stands for is distribute, combine your like terms, move the smaller x, and then from there you end up with a 2-step equation, which most of you guys just know how to solve at that point. So the first thing you want to do is distribute if you can. Now in this problem that we're looking at here, there is no distribution, so we're good. The next thing we're going to do is combine like terms. So on the left side of my equation, I have 2 like terms that I can put together, the 3x and the 7x. 3x take away 7x is -4x. And then we'll bring down the -3, the equals, and the -7. Next it says move the smaller x. Now that step only applies if you have an x on both sides of the equation, which we don't. So I'm not going to worry about this step. And the last thing to do is just solve it. So from here, most of you guys know how to solve a 2-step equation fairly well. The answer is x equals 1. Okay, let's try another one. All right. Next one. So step 1 is to distribute. I do have some distribution here. So if I distribute the 4 inside to both terms, I end up with 12 plus 20r. Next step is to combine like terms. On the left side of my equation, I have 2 like terms that I can combine. Next one says move the smaller x. Now in this case, I don't have a variable on both sides, so we're going to skip that step. And from there, we just solve. And there you have it. Let's go ahead and move on to another one. Okay. So for this problem, we have distribution. We do right here. I can distribute that 5 in. Now let's see if we have any like terms. Now on the left side, there's no like terms, and there's no like terms on the right side. Now some of you guys might think, well, wait a minute, aren't these p's like terms? Well, they are, but they're on opposite sides. And so for this step, when I say combine like terms, I mean combine any terms that are the same on the left side, and then combine any terms that are the same on the right side, but don't mix the sides together yet. We'll get to that. Next thing we're going to do is we're going to move the smaller x. In this case, we could say p, because we're not solving for x, we're solving for p. So in this case, we do have a smaller p. Which number is smaller, negative 15 or positive 4? Well, negative numbers are smaller than positive, so I'm going to move the negative 15. The way I'm going to do that is I'm going to do the opposite. So this is minus 15. I'm going to add 15, so it cancels over here. And whatever I do to one side, I have to do to the other. So I'm going to put it over here. And that ends up making 19p. And from there, we should be ready just to solve it like we would normally solve it. Add 32 on both sides. And I'm feeling like it's probably going to be p equals 3. Right. Now we're going to move on to a whole new topic. We're going to talk about solving systems of equations by graphing. The way you do this is by graphing each line and finding out where the lines cross. Okay, so let me color code these a little bit. I'm going to graph this one first in blue. I'm going to start off at 3. I'm going to go down 5, right 3. Now for the other one, I'm going to go ahead and do that one in green. Starting at negative 1, I'm going to go down 1, right 3. And the way that you solve a system of equations is basically you're looking for the x and the y that works for both equations. Now, any point that is on the line works for the equation. So, in this case, the point that is on both lines is the point where they cross at. And so that is the solution. The solution would be 3, 2. On this one, the solution would be the point, once again, where the lines are crossing, which is right here. And the coordinates for that one are negative 6, positive 6. This is a no solution situation. If the lines don't cross, there is no solution to the system of equations. Now that's solving by graphing, but usually to solve systems we end up using either substitution or elimination. This one's telling us to use substitution. So a little while back I gave you guys some steps to solve this. First thing is you want to underline, you don't have to do these first few steps, but I find they're helpful for teaching at least. Underline the lonely letter is what I call it. the letter that's all by itself. It's the one that says y equals or x equals. So where is it at? Right here. Y equals. So there's my lonely letter. Sometimes you'll have two of them, and in that case, just pick one and underline it. The next thing you're going to do is you're going to circle what it equals. Circle what it equals. So my lonely letter equals negative 2x minus 21. Step 3 is you're going to plug what was circled into the other equation. Okay, so now since y equals negative 2x minus 21, I'm going to plug that in for the y in the other equation. I'm allowed to do that because that's what y equals. So I can replace y with whatever y equals. Just like that. From there, you're going to solve. So we start with distribution. Multiplying the 5 inside gives us the negative 10x minus 105. Next, I'm going to combine like terms. And from there, two-step equation. Let's see. I'm thinking that would be 96. And then if we divide both sides by negative 12, I believe we're going to end up with negative 8. Now it says just find the x-coordinate, so just technically we could stop there. But a lot of times you do want to go back and find the y value. So what you're going to do is you're going to plug and solve to find the other variable. So I'm going to take this answer here and plug it into one of the original equations. Now it doesn't matter which one you use because both of them should give you the same answer. That's the point of equations. However, I would advise using the one that has a lonely letter because it's usually easier to use that one. So I'm going to replace x with what I got for x. I got negative 8. So the two negatives there, negative 2 times negative 8 makes 16. And 16 minus 21 is negative 5. So there's the y value and the x value. Those two lines would cross at the point negative 8, negative 5. Okay, and that's how you solve a system of equations by substitution. Right, let's take a look at another example here. Just to repeat, the reason I'm going to do this example is to kind of demonstrate something to you. Not so much just to do more of the same thing. So find your lonely letter. Let me circle what it equals, plug it into the other equation. Distribute. These cancel, and we're left with a weird answer. When you're left with a statement that is not true, negative 6 is not equal to 2, but all the x's are gone, that means there's no solution. In other words, if you were to try to graph these two lines, they wouldn't have any points in common, and that would be because they're parallel. All right, let's go ahead and move on to another problem now. For this problem set, we're going to be using a different strategy to solve it. We're going to be using elimination. Now, technically, it's possible to use substitution on these as well. You just have to get one of the letters by themselves. But a lot of times it doesn't work out very well because you end up with fractions everywhere if you try to do it. So that's why it's good to have this other method. So this other method, known as elimination, is basically going to be you trying to get one of the variables to cancel out. That's why they call it elimination. So the first thing you want to do is pick a variable that you want to cancel. Okay, so let's go ahead and cancel out the y's here. Okay, I want to cancel out the y's. All right, the next thing that you're going to do is you're going to multiply, make a little space for myself here. You're going to multiply the top equation and the bottom equation by something so that those come out to be the same. Now, we've got some pretty big numbers here. Wouldn't you guys agree that these are some pretty big numbers? So I think what I'm going to do is, before I go any further, I'm going to actually change these equations. This is not something you usually have to do, so I'm not going to include it in my steps over here. But what I'm going to do is I'm going to start by rewriting these equations a little bit just so I can end up with some smaller numbers. So real quick, what divides into all three of these numbers? 9. 9 can go into all 6 of those. So I'm going to divide all of those by 9. And if I do that, I'm going to end up with the following result. What about the second example? What goes into all three of those? All three of those can be reduced by 12. So if I divide the first one by 12, I get 3. Second one, I get 2. And last one, I get 1. So you don't have to do that, but if you don't, you might end up working with some really big numbers, which is kind of unpleasant. So I'm going to do that. Anyway, that's not something you typically will need to do, but it may need to happen if you have these numbers that are this big. So step 1 is to pick a variable. Let's say I wanted to cancel out the x's. Okay. Step 2 is you're going to, this is how I call it flip and distribute. Flip and distribute. But flip and distribute what? The coefficients. So remember, I chose to cancel out the x's. So what I'm going to do then is I'm going to take the coefficients of these x's, -6 and 3, I'm going to flip them. So the 3 is going to go on the top now, -6 is going to go on the bottom, and I'm going to distribute them into the equations like this. And what that's going to do is that's going to create for me a whole new system of equations where something special happens. I'll show you what that is. Just a moment. Now that's pretty much most of the hard stuff that you need to know how to do. However, there is a third step. The third step is to change the signs in one of your equations. Change the signs in one of your equations. So what I'm going to do now is I'm going to change all the signs in this top equation. You have to do it to all three. And then the fourth step is to combine downwards. So I'm going to put the 18x and the -18x together and they cancel. And that's why this is called the elimination method. By multiplying the 3 to the top and the 6 to the bottom, we ended up with the same number here on the top and bottom. And because of step 3, I made them opposite signs, which results in them canceling when we add it together. That's why we call it the elimination method. Now, usually what's going to happen here doesn't usually happen, but in this case it does. The y's also cancel out, and so do the 6's. Everything cancels out, so I'm left with 0 equals 0. That's a little bit like the same scenario we had in the last problem we did with substitution, but there is a different outcome here. Notice that those are equal, so that's a true statement. When you end up with something like that, then what we say is that there are infinitely many solutions. Now, usually what happens after you combine downwards, though, is you'll have one variable left and you can solve. And once you know one of your variables, you just plug it in and solve for the other one. But in this case, they both canceled, so we're not going to use those steps. Let's go ahead and do one more example where that's maybe a little bit more normal. All right, so here's this one. Once again, if you want to try to reduce these equations, you can. Notice the top one, I can't really do anything with that. Nothing goes into 5, 6, and 9, so I can't reduce that equation at all. But the bottom one I can reduce by 3, so I think I'll start by doing that. Okay, so step 1, pick a variable that you'd like to cancel. I want to cancel, let's do the y's this time. So I'm going to take the coefficients in front of the y's, I'm going to flip and distribute them. So I'm going to put the 3 on the top, the negative 6 on the bottom, and I'm going to distribute all the way across. And that's going to result so now we're going to end up with negative 15x minus 18y equals negative 27. And on the bottom, we're going to have negative 6x minus 18y equals 54. Okay, now step 3 is to go through and change all the signs in one of your equations. It doesn't matter which one you pick. I'll go ahead and do the top again, just because it looks easier to me to do that one. I don't like a whole bunch of negatives. Now we got that. Step 4 is to go ahead and combine downwards. So 15 take away 6 is going to be 9x. The 18s go away. You should always have one of your variables canceling at that point. And then adding these things up, I end up with 81. Step 5 is to solve for x, or whatever variable you have left. I get 9. The last step is to plug this answer into one of your original equations and solve for y. So I'm going to go ahead and plug my answer for x equals 9 into the top equation. This is what I get as a result. So I end up with negative 45 here. Add 45 on both sides here. And that's going to give me the following. Negative 6y is equal to 36. And division will give me my final answer, which is negative 6. There we go. So there's our two values for x and y. That's what's known as the elimination method. So we've covered the 3 different strategies for solving systems of equations. We've talked about linear equations, we've talked about systems of equations, and we're moving on into our last topic here, which is functions. Linear equations are functions as well. Basically, what a function is it's an equation where if you plug a number in, you get one number out, only one number. That's what's called a function. Okay? You can do all kinds of things with functions. In this case, we're being asked to add 2 separate functions together. So, g of n plus f of n. G of n is equal to 3n plus 2. F of n is n cubed minus 2n squared. At this point, we're going to add these together. Now, notice that there are no like terms here. None of these will combine. So what we're going to do is we're going to just put them in descending order, highest exponents first, and working our way down. But if you can, make sure you combine any like terms that you may have. Let's take a look at another example. Here's a multiplication example. So in this case, I want to do f of t times g of t. So f of t is 2t minus 5, and g of t is t squared minus 5t. Right? And the way that we've learned how to do this is with a box. So make myself a little box here. We'll put 2t minus 5 on the top, and we'll put t squared minus 5t on the side. And we'll go ahead and multiply our terms to fill this in. And you also want to see if there's any like terms that you can combine. It looks like this -10 and -5 can be put together. So like I said, we have our like terms in the middle. We can put those together. So let's go ahead and do that. That. So that would be multiplying those two functions together. Moving on a little bit. Now, notice something here. This is asking for g of -1 minus h of -1. So first of all, let's figure out what g of -1 is. What that means is you're going to plug -1 into the x for the g function. So that would look like this. Now, if we simplify that, we're going to have -3. And then adding the 4 to it, we end up with 1. We're going to do the same thing here for the h. Let's do that. We're going to plug in -1 to the h function. So the double negatives become positive. Which means that h of -1 equals 6. So now I know that g of -1 is 1, and I know that h of -1 is 6. So I want to find out what is g of -1 minus h of -1. We just did a whole bunch of math, and we proved that g of -1 is 1, and we proved that h of -1 is 6. So if we go ahead and subtract those now, we're left with -5 as our final answer. So in the cases where you have numbers in here, you have to plug them in first before you do the operation. Here's another one where they have numbers on the inside. So let's start by finding g of 4. G of 4. Next we'll find f of 4. See, what would that be? We're about 48. So we've got our two answers there. G of 4 is 17 and f of 4 is 48. And so if we want to do g of 4 divided by f of 4, it would really just be 17 divided by 48. And my guess is they would probably just write the final answer as a fraction and reduce it if possible. But in this case, it doesn't reduce. So there's our final answer. This one's just basically asking us to plug in some numbers, but I thought I would give this example because sometimes people have trouble with order of operations with these things. So first of all, I'm going to rewrite the entire equation with parentheses instead of x's, and inside of those parentheses now I'm going to put the negative. And here's the place where a lot of people mess it up, is they forget that you want to do the power first. You do not do -5 times -2 first. You do the power first. So it's going to be -2 to the second power is a positive 4. After that, you do your multiplication. And after that, just going left to right, you combine your numbers together. So -20 and -12 is -32. Bring down the 9. And then -32 and -9 makes -41. Okay. Powers first. Here's another similar example. On this one, we're plugging in an actual expression, though. We're not plugging in a number. So, once again, we're going to start by rewriting the entire equation. But instead of x's, we're just going to put parentheses. And in the parentheses, we're going to put x minus 2 now. All right. Now this one here is the one that's the biggest pain in the butt. You got to know how to do that. X minus 2 squared, I'll show my work over here on the side. X minus 2 squared, what that really means is x minus 2 times x minus 2, which is a box problem. There's also a shortcut for this that we learned a little while back. I'm not going to review it at the moment, but if you remember it, please feel free to use it. These two negative 2x's come together to make a negative 4x. There we go. So this part here in the box simplifies a little bit. It becomes x squared minus 4x plus 4 because of the box method. So we do our power first, just like on the last one. It's just that this time it required a little bit more algebra. Then we do our multiplication, which in this case takes the form of distribution. And then finally we combine all of our like terms together. There's no term that's like the 2x squared, but the negative 8x can be combined with the positive 3x to make negative 5x. And then the 16, the negative 6, and the 1 can all go together to make 11. All right. Here's another thing that we can do with functions. Instead of plugging something in, we can just do operations on the function. So for instance, I can take my f function, which is 3x minus 1, and I can multiply it by negative 4 and add 5. So in other words, starting like this, I can replace f of x, the whole thing, not just the x, but the whole thing, the whole function, with what f of x equals. F of x equals 3x minus 1. And from here, you just simplify it. Distribute and combine like terms. Okay? So you have inside changes. Those are things where you plug numbers in for x, like the last two problems, but you also have outside changes, which is where you take the whole function and you just do these operations to it. Okay? And I believe the next problem combines both of those together. Let's take a look. Yeah. All right, so in this problem we have inside things here. We need to plug this into our function, but then after we do that, we also need to multiply it by negative 2 and subtract 5. So here's how I'm going to suggest you guys approach these. First of all, ignore the 2 and the 5, the outside numbers, and let's just focus on the f of x plus 4. So let's do that first. F of x plus 4. You're just going to be plugging that into your equation. So the ones that are in parentheses, that's what you plug in for x in your original equation. Okay. Now we're going to go ahead and simplify it. Now for this problem, you have to do a box method. We demonstrated that on number 25, I think it was. So if you missed it, go back and take a look at that. But here we're going to do the box method for this. There's also a shortcut if you remember it. There's that. The next thing that we're going to do is we're going to go ahead and do any sort of distribution that we might have to do. Here I've got to multiply the 2 inside the parentheses there. And then finally we're going to combine like terms. X squared has no like terms. 8x can be combined with negative 2x to make 6x. 16 and negative 8 and 1 can be combined to make 9. Okay, so now after having done all that work, clean this up a little bit, we now see that f of x plus 4 is equal to what I have down there in the bottom, x squared plus 6x plus 9, right? So after you've done the f of x plus 4, the one that I put a box around in the very beginning, after you've done that, we're going to get rid of it, and in its place, we're going to put what we found it to be. It's x squared plus 6x plus 9. And from there, you just go ahead and do whatever math is indicated. So in this case, we're going to distribute first. And then we're going to combine any like terms. The 18 and the 5 can go together to make negative 20. And there's our final answer. Okay, so once again, start by finding what the f of whatever is first. Once you know that, then replace that with your answer to get the final result. Inverses. That's something that we did back in logarithms actually pretty recently, but I figured I would put it here in the function review section because it does have something to do with functions and how you write them. So back when we did this, I gave you guys some steps. The first thing you do is you replace the g of x, or whatever it is, replace the g of x with y. Okay, so that's going to be our first step. The second step is to switch x and y, or whatever two variables you're working with. So in this case, I'm going to put the x here, and I'm going to put the y here, so I switch them. That's what makes it an inverse. An inverse is where the output becomes the input, and the input becomes the output. The last part is the hard step, but you need to solve for y. You need to get y by itself. And the reason that that's hard is because every problem is a little bit different. So you're kind of just relying on your Algebra 1 skills here to get you through this. But in this particular case, if you wanted to get the y by itself, the first thing I would recommend doing is getting rid of that 5 in the denominator by multiplying everything by 5. Okay, that way it's gone. And now we have just 5x equals 20 minus y. The next thing I would do is maybe move the 20 over here. So I end up with 5x minus 20 equals negative y. And we don't like that negative there either, so I'm going to divide everything by a negative 1 to get rid of it. And there's my final answer. Now, actually, though, let me back up. What we're supposed to do at that point is we're going to replace y now with a g of x function again, but this time we're going to put a little negative 1 here. And what that means is that this function, negative 5x plus 20, is the inverse of this function up here. And if you guys forgot what an inverse is, I'll quickly remind you. Let me make some room here. An inverse function is one where the input and output are reversed. So let me demonstrate what I mean by that. So let me pick a number to plug in here for x. Let's say I plugged in 5 for x. And then I simplified it. That means that g of 5 is 3. So g of 5 gives me 3. But for my inverse function over here, something interesting happens. If I take this function and plug in 3 to it, let's simplify it and see what we get. This is negative 15, and that's going to be 20. you get 5. So notice that for the original function, plugging in 5 gives you 3, but for this new inverse function, plugging in 3 gives 5. So they just basically reverse the input and output. That's what an inverse is. But these are the steps that you go through to do it. So this last step I did where I was showing you guys what an inverse is, you don't need to include doing that, but I was just making a point. All right, what else do we got? These questions here, I plan on just making extra credit. You don't have to do them. They're not that difficult, but basically, just thought the reason I'm making them extra credit, I don't think we ever did anything like this in the class, but they're really not that far from the things that we have done already. So nice little way to kind of just stretch you guys to think a little bit more. So in this case, it says find g of h of x. Now what that means is you're going to plug the h function into the g function. So what is the h function? The h function is x squared minus 5. So that's what we're going to be plugging into the g function. And how do we do this? Well, I mentioned you start by writing the g function, but where the x's are, we're going to leave blanks, and in those blanks, we're going to put the h function. And what that ends up giving us is 3x squared minus 15 plus 1. And then we go ahead and combine our like terms, negative 14. So there's our final answer. That would be g of h of x. Okay, so g of h of x just means plug the h function into the g function. And the h function is x squared minus 5. And so plugging that in, you result with 3x squared minus 14. And last problem I'll go over with you guys is a similar question, but in this case, we have a number. And like I said, anytime there's a number, you start by finding that first. So let's find out what f of negative 3 is. F of negative 3 means I'm going to take this n squared plus n function, and I'm going to replace the n with 3, which is 12. So that means that f of negative 3 is 12, which means that this is really g of 12. Now what does this mean? That means I'm going to plug 12 into the g function. So the g function is 2 times n minus 2. In this case, we're replacing the n with 12. 2. Okay. These are what we call composite functions on numbers 29 and 30. They're called composite functions. Just making them extra credit, but they are something that are good to know for future math classes. Okay. That's it for this week.